Okay, the recording has started. I think we can start the session. So I am Said. Here is Nafis with me. He is my colleague at WellDev. Nafis, say hello.
Hello, Said Bhai. Thank you for inviting me to your session.
Hello, Nafis. So today, as we discussed before, we will be hosting a session on retry design pattern, and we will be trying to cover so many real life examples that why we need retry design pattern, in which type of scenarios we need it, how does it benefit our real life softwares. So we will be looking onto the very basics and different types of examples. So I am sharing my screen now. I think it will be interesting. It's going to be really interesting and informative. So I have shared my screen. Can you see it now?
Yes, I can see.
Okay. So we are going to the next slide. So at first, let's start with the very basics. Like, let's say you are browsing internet, maybe you are using Facebook or LinkedIn, and your Wi-Fi is dropping frequently. So what do you do when your internet drops?
I usually reload for a few times and then try to turn on and off the Wi-Fi router. Yeah.
Right. So when we reload, we normally think that if we reload, it will be okay automatically, because we think if we reload for second time or the third time, it is going to be recovered, because there are so many errors in real life that are automatically recovered after a certain period of time. Right. So in case of software development, when we are building a software, we also have so many scenarios like this. We can see it in the next slide. So Nafis, can you tell, like, in a real life software where there are multiple servers, multiple APIs deployed in different servers, how can retry pattern help us?
So there could be like scenario when a network failure happens. So in that time, an application lost connectivity for a short period of time. So in that sense, retry mechanism really helpful. Maybe the for the first time the connection is lost, but for the second time or maybe the third time, the connection is works fine. So in that sense, retry mechanism is really useful. And there could be like a scenario, maybe a server is down or is under maintenance, like developers are upgrading it, and that time an user is trying to access some data to request to the server, and it fails. So in that time, the retry mechanism is very useful.
Yeah, so
And yeah.
also there can be some unexpected bug that no one knows about, that no one knows why the bug has happened, but if we have the retry design pattern in place properly, then maybe it will be recovered. For example, in the second point, which is server down, let's say that we are deployed an API, and the API is trying to hit the database, but the database server was down for a few seconds. Let's say the database server was down for 10 seconds. So when the APIs were hitting in between those 10 seconds, they were not getting any data. So, but if we have a retry mechanism implemented in our API, so the users is going to get the proper data after a certain period of time, right? So we haven't also worked on this that much before, so we are little less clear, but still we are trying to explain the basics. So let's go to the next slide. So I think this slide is at least self-explanatory, like at least little clear. It will be clear to the viewers that we are trying to explain. Right.
Yeah.
So in the next slide, we will be try to look at the very real examples. For example, let's say I have two servers. When a user signs up in one account, the okay, sorry. Okay, so let's think of an account sign up process in Facebook or LinkedIn. Whenever we sign up an account, what happens? The Facebook emails us that you have successfully signed up properly. So let's say the email got lost. For example, there was the server down or network failure, anything, and the email got lost under the hood. And if we have retry design pattern set properly, the on the retry mechanism, second retry, third retry, we are getting the email properly, right?
Yeah.
But Nafis, let's say that I don't want to implement retry design pattern. Is there any loss? Like if the email is lost, I don't care. Why do I need to increase the complexity of my software?
Yeah, it might be necessary sometimes, or we can sometimes ignore it. But if it's necessary for your sign up, so it's crucial. We always need this retry mechanism in these important scenarios.
Okay, so if it is a normal email, like the email is containing just a message that you have successfully signed up, and if this email is lost, that is not a total loss of me. But if the email is containing important data, for example, OTP, SMS, password reset link, like if the email is containing sensitive information, then we must have retry pattern, and we cannot ignore it. Like for example,
Yeah,
when
yeah.
when you use payment through your mobile, you are doing online payments, there is a OTP sent to your phone, or there is a SMS which is containing the verification password for only 60 seconds, which is valid for 60 seconds. So you must have to ensure that your software is not missing retry pattern in this type of scenarios, right?
Exactly. Yeah.
Also, we can see in the last point the transactional data. For example, as we have discussed, our banking OTPs are also transactional data, and there can be many other scenarios where we need retry design pattern. It is not just about email sending. For example, in a banking application, there are lots of transactions related to money, and if a single transaction fails, there can be a total problem in the system. So can you explain some other things? You have said me before that you have implemented retry in Azure. Can you explain a bit?
Yeah, so I work in .NET in 12 So in one of my projects, I need to maintain vulnerability monitoring. So for that, since I had to implement uh, a NuGet package updating mechanism. So there is already a service like Dependabot, which is actually supported in GitHub by default. But we were actually using Azure DevOps for our repositories. So in that scenario, I wrote a pipeline in Azure DevOps, which actually hosted in Ubuntu server, and it had a script for Dependabot, which actually fetch the package information from all the package information from the URL. So some of the package URL was failing after some time because there was a timeout situation. So in that time, I implemented a retry mechanism. Basically, it retry for a maximum 3 times, and there was a like incremental retry.
Okay,
Like
one question.
first
Okay,
time, yeah.
I have one question. So you said you have implemented retry mechanism. Is it inside the Azure pipeline?
Yes,
So
it
you
was
have
inside.
so you have
Yeah.
implemented your retry mechanism inside the Azure pipeline. So I was trying to make it clear to the audience that it is not in the normal local development in somewhere. It is in the Azure pipeline. So can you say in one or two lines that how is it helped you? How does it help you?
So even if there are some URLs get timeout, but with retry mechanism, we can actually try again, and then it works the next time. Also,
Okay,
I
so
implemented a caching mechanism in the pipeline so that we do not have to start everything from the scratch, like caching what we done so far and then continue from the next step.
okay, so let's talk about Azure pipeline now. We can discuss caching another day. So, as far I understand what you have explained, that in your Azure pipeline there are a retry mechanism. The task of the retry mechanism is to retry the failed downloaded NuGet packages, right? If any NuGet
Exactly.
packages fail to download from, you are mentioning about URL. So that URL is the NuGet package download URL, right?
Yeah, yeah, yeah.
So this is also one real life scenario. For example, we talked before about email sending. If an email containing OTP SMS fails, we can retry. And now after Nafi said that his retry mechanism has nothing to do with emails, it has something to do with downloading packages. So we can clearly understand that retry is not only bound to sending emails, there can be thousands of other scenarios. So email is
Yeah.
just a basic example we talked here. So okay, we can go to the next slide. So I will ask Nafis a question. let's say I have designed a software where I have set retry mechanism everywhere. Like whenever there is an error, the application must retry. And when a user is trying to sign up with a wrong password, let's say he is trying to log in and the password is wrong. So it is a very expected behavior that it will be failed, it will be an error, right? And my retry mechanism is doing like retrying the failed login, but it should not be the case. So I have produced a bug in the system by implementing retry globally, because now the failed login, the wrong password, the wrong username, everything is getting retried. So my system is now in a total problem. So what do you say that how can it be handled?
Yeah, so there could be a lot of mechanism to implement retry, and also there is some scenario we should not use not retry, because in some scenario there could be no use of implementing retry. For example, if we talk about the I mean 404, 401, 400. So basically all sorts of 400 to 499 error codes we can consider for not retry scenarios,
Yeah, so
because
we have
there are errors that yeah, we are okay with.
we have already shown that in the slide. I was trying to tell you that. So in the slide we have written that if a user is unauthorized, the status code is 401, or if a user has not enough permission, the status code is 403. So what does this error code denote? Does this error code is some sort of unexpected error or an expected error?
I think these are expected error.
Right. So we must avoid our retry pattern when the error is actually an expected error. So we have to create a barrier that which type of errors were totally unexpected, we can only implement retry design pattern there. So if I say that all the error codes more than 500 can be considered for retry, do you agree?
Yes, because 500 error is vague, we cannot understand actual reason.
Exactly. Okay. So let's go to the next slide, which is a very fundamental concept in retry design pattern called back of time. Like as we are constantly telling from the beginning of the session that retry, retry. So, but how after how delay you should retry? How much should you wait before the next retry? So Nafis, can you explain this? Like incremental back of time. Can you explain this one?
Yeah, so I also use this incremental back of time. Like it could be linear, exponential, or it could be Fibonacci. I mean, you increment the next retry than the previous retry. So it actually necessary. Why? Because if you incremental back of time, it actually reduces the risk of not a failed response, because there could be a situation like we don't know how much time it would take
For
to get a
example,
response.
let's say server is
Yeah,
down and or the developer are maintaining it. So Fibonacci would be good or exponential would be good, because if something has crashed, it maybe will not be recovered so soon. So then you will
yeah, yeah.
use exponential or Fibonacci. So you said you applied retry design pattern in Azure pipeline. Can you say that was exponential or Fibonacci or linear?
It was linear, because I like plus 30 seconds every
So
time.
if the first retry is after the 30 seconds, the second retry is after the next 30 second, not 30
Yeah.
multiply 30 or exponentially grow. Okay. So
No, no, no. Yeah.
so is incremental back of time a perfect solution for all cases? Like there can be scenario where this would be a bad idea. For example, I need a OTP for verifying something, or I am trying to take off money from ATM booth and a OTP must come to my phone, and I cannot use incremental there because I don't want it to be so delay. So the point is what I am trying to say. We have to know that in which type of scenario exponential back of time can be good, and in which type of scenario we should never choose exponential. We should go with linear or constant back of time. We have to also divide the scenarios that in which scenario we are dealing with. So there is
Exactly.
one more thing, random back of time. I think it is very important and it is very interesting. For example, a server cannot handle more than 1000 requests. You consider it. Let's say a server cannot handle more than 1000 requests at the same time. So let's say 2000 users hit that server at the same time. What will happen? The server will crash, right? So
Exactly.
if the linear incremental time is set there, what happens that 2000 people hit the server at the same time, the server doesn't respond properly, and the linear back of time does what? That more 2000 requests are going linearly in the next linear after the next delay. So again 2000 requests are hitting the server at the same time because it is linear back of time set in the code base. So this error will never go. So if it is random back of time, the different users are retrying after different amount of interval, then the server load will be reduced. Are you clear what I was trying to say?
Yeah, what you are saying there is really, I agree with you. But I
Uh,
think, yeah, you are right. But I think there should be a upper bound for the random backup time, because it could be like 1 second and then 1 hour. So yeah, what do
Yeah.
you think?
Yes, you must have a upper bound and lower bound. That's good. So we can go to
Yeah.
we. I think we have explained the concepts basics clearly. And if anyone wants to work with this, if any viewer who is watching us wants to practice this or do R&D in his personal project or his industry project, he will be doing all the investigations, more and more investigations by himself. What is we have not presented today, like there could be much more on retry design pattern. So we are encouraging everyone to uh, investigate more if you want to learn it properly. So let's go to the next slide. Don't fall in the infinite loop of retrying. So Nafis, what do you understand by this?
Yes, I think we should not implement retry in everything, because we should not, because we we do not need retry mechanism in every scenario. There could be some sort of scenarios where retry mechanism could make the immediate, I mean, we should use it carefully. There could be some scenarios where we don't need to implement it.
No, so what I was trying to mention is, let's say that a server has totally crashed, a server is dead, and no matter your code has a proper retry design pattern implemented, the code is never going to get proper response even after retrying. So even if it is retrying 1000 times, it is not going to get the proper response because the server, let's say, it is hacked or it has been killed or it has been totally destroyed. So you must have a retry count, what you have said before.
Yeah, yeah, exactly. We should have a count for maximum retry.
So that was the concept behind this infinite loop, that if a server is totally dead, we don't need to make our API heavy by retrying 1000 times. So what can be the maximum retry ideally? Like when you implemented in Azure pipeline, what was your maximum count?
It was 3.
Okay, three. So in different software, it can be five, it can be 10. We can study in Google, we can study different things that what do other experts recommend in what type of softwares. Also the retry time, as we have said before, constant time, incremental time, it is also it depends upon what type of software you are building, what type of solution is needed. You cannot just say that I will apply exponential back of time in all the softwares. Maybe it will be bad in some cases. So that's all about it. Today we have nothing much more to explain. I think that was good. Nafis, what do you think? Do you think the session
Yeah,
is
yeah,
good?
yeah. It was really fruitful session,
Uh,
and thank you. Thank you for inviting me. I
okay.
think you should continue the session like this more and more.
Okay, so I actually want to make much more videos like this in future. But one thing is sometimes we get nervous in the middle of the recording. We get often nervous that what we should say, what we should not say.
Yeah.
But actually, I think if we continue this, this thing will be we can recover this better. We can do better, and we would expect our viewers to give us suggestion if they have any, that how we can improve it. I would really love to get more
Yeah.
suggestions how we can improve. Also, if they have any good design pattern of their choice, if they want that we should make a video on xyz design pattern which is really important, we can also study that and make another video on that, right? Yeah.
Yeah.
So I think we can
Thank
end
you.
the video for today. That's good. Okay. Thank you, everyone. Nafis, say bye bye. Bye.
Yeah. Bye bye.